Hi guys, BuildZoid here, and today we're going to be taking a look at a not really all that practical DDR4 Z690 overclock. Like, I did stability test it, but as you can see, right, we've got mem test, linpack, so yeah, we'll go through that. I did do some stability testing on it, but it's not very practical because basically, you know, I basically just sat down and thought to myself, so what about Gear 2? In single rank with Samsung B die. And so after, asking myself that question, which probably doesn't require an answer because you shouldn't do that, but I was still wondering, I pulled out the Gigabyte Z690 Aorus Pro DDR4 board, mostly because this motherboard has a safe boot. So while ultimately this motherboard is not it tops out at worse settings than some of the other boards. The thing is, when you're just testing stuff, having a working safe boot button is so much better than not having a safe boot button. So for rapidly testing different combinations of settings and sort of getting a feel for the behavior of the CPU and the memory kit and that kind of thing, I actually really like the board, mostly because I can just safe boot anytime I screw up, which with a lot of the other motherboards, you just kind of have to sit there and wait for them to reset. And also it has a postcode, so you actually know what's wrong, whereas no other DDR4 motherboard has a postcode, which is absolutely bloody just insanity. Anyway, so yeah, I pulled out the Aorus Pro DDR4 because it's not the best DDR4 overclocking motherboard, but it is certainly the least, it's the nicest to test on, which doesn't really make a lot of sense, but yeah, that's just how I feel about it. Is because ultimately I think I could probably get better results out of the tough, but with this I know what's going on before I get into the OS, so that's kind of that. Anyway, the memory kit I ended up choosing is this Teamgroup T-Force Xtreem ARGB kit, which was provided to me by Teamgroup quite a while ago. And this is just 3600 CL14, single rank Samsung B die, so 8 gig DIMMs, and yeah, we've got two of them in the system. And then, of course, the CPU is the 12900K, and that's just on the air cooler because, this is just for quick testing. I'm going to switch motherboards soon enough to probably test something else. And so dealing with the whole mounting hardware for a water cooler is just not something I'm particularly interested in. So let's take a look at the actual settings that I ended up with. And since, like I said, this is Gear 2, so it's an interesting one. If we look at IDA, right, we can see lots and lots of memory bandwidth, which is what you'd expect from Gear 2. But the latency is sort of in that DDR5 territory rather than the DDR4 territory, right? With DDR4 in Gear 1, you should be pushing somewhere around 40 to maybe 46 nanoseconds. With DDR5, you're looking, around 50 nanoseconds or more, generally speaking. And so this is very much sort of in DDR5 latency territory, and it's not in DDR5 memory bandwidth territory because it's still DDR4. And DDR5 is not only running much higher, effective memory speeds, it's also running, due to how it works with the sub channels on the memory, on each memory channel, it actually gets more effective bandwidth even at even relative to the settings that it's running at. But still, this does get more bandwidth than what you would be able to get in Gear 1. Yeah, so there would be some workloads, say, Y-Cruncher. Y-Cruncher loves this, right? Y-Cruncher, this is, I think, the fastest Y-Cruncher I've gotten out of this motherboard so far. That's actually, stable, which, admittedly, getting a fast Y-Cruncher that isn't stable is kind of hard because Y-Cruncher is quite the memory stress test. Even in its 2.5 billion configuration, it is quite hard on the memory system. So, I generally like to run Y-Cruncher before memtest because if Y-Cruncher crashes, there's no way memtest is finishing. Right? And Y-Cruncher takes 81 seconds, whereas memtest takes quite a bit longer. Yeah, so Y-Cruncher really likes all the extra bandwidth. Linpack doesn't seem too upset by the extra latency. It also hasn't seemingly benefited too much from the extra bandwidth. Also the fact that basically dual rank at 3900-ish, or I think it was 3866. Dual rank at 3866 gets roughly similar Linpack performance, with lower latency and much less memory bandwidth. But that's kind of the thing. So yeah, Linpack on Alder Lake is actually far more latency sensitive than on some of the past CPU architectures, which is kind of interesting. It's especially noticeable on DDR5 because DDR5 has so much memory bandwidth that Linpack really doesn't care much for any extra memory bandwidth at that point, and it really becomes more of a latency benchmark. Yeah, so it does, like, Linpack's not too upset with these settings, even though IDA is. But that's just kind of like Gear 2 things. Like, being in Gear 2, you just get a ton of extra memory latency, and you're just kind of stuck with that. But in return, like, for that latency trade, you do get a lot more bandwidth, and so, Linpack ultimately is a little bit faster. And Y-Cruncher is quite a bit faster, if I remember correctly. I mean, you can just go check the other the other memory overclocking video that I did with this board. Memtest ran, and it was running quite quickly, 25 gigabytes per second, so, which, benefits of Gear 2. And then here's the actual settings, which I think it'll be easier to just look at those in the BIOS. So I'm just going to quickly take a screenshot in case I decide that, and decide to change something. And let's restart. Because, like, the issue with this whole Gear 2 overclock is, like, so you get sort of DDR5 style. It's still slightly less latency than what you generally see with DDR5, but you sort of end up in, like, DDR5 latency territory without the DDR5 memory bandwidth to sort of compensate for that in a way. The thing is, I also just generally don't really like the IDA benchmark. There's all kinds of issues with it, but... Yeah, so where was I going with that? Yeah, so you get a bunch of extra memory bandwidth in Gear 2, but you lose latency. And the funny thing about that, though, is that most workloads that really need a lot of memory bandwidth also generally need a lot of RAM. Okay, like, generally speaking, if you need to move a lot of data around, there's probably a lot of data sitting in the memory. And single rank Samsung B die is certainly, very fast. It's just not a lot of RAM, right? Like, it's 16 gigs of RAM. And so that's kind of the main that's where I'm really conflicted with this. Like, there's technically workloads that would benefit from this style, like this level of memory bandwidth. And it's, like, this would be much cheaper than going with DDR5, and I'm not sure how it would necessarily compare to DDR5 in performance in those memory, like, bandwidth limited workloads. But with DDR5, at the very least, you'd easily be on, like, 32 gigs of memory without too many problems. With DDR4, at least with Samsung B die. There's other DDR4 options if you want high density. But specifically with Samsung B die, it's like, yeah, you're not getting any memory capacity out of this, so I'm not sure what you'd be doing with this. Anyway, let's take a look at the settings. I mean, Geekbench 3 loves it, but, like, Geekbench 3, you could just run that on DDR5 and you'd get, better results. Anyway, so let's take a look at the settings. So for the primaries, we're just at 1717, 1728, which, yeah, that 4600, that's pretty good, and it does require 1.55 volts. Also, with these higher memory speeds, you do need quite a lot of system agent. I personally wouldn't go above 1.4 volts for long-term operation on the 12th gen CPUs. DRAM VDDQ up at 1.5 volts. I actually have no problem with that. I don't think, like, as far as I'm aware, 1.5 volts VDDQ really shouldn't cause any issues. So, yeah. Then also a little bit of extra ring PLL. That can help sometimes with high memory speeds. And then also a little, like, 120 millivolts of PLL over voltage. Both of these are completely safe for long-term use. Like, it really isn't a large voltage increase over stock operation. Because technically these look like offsets, but they're always offsetting. Like, the base value for something like the memory controller PLL voltage, that doesn't change. It's always going to be an offset off of 0.9 volts. So, yeah, you don't have to be concerned about that. So that like, I wouldn't have any concerns running that 24/7. The training voltage is reduced because this is on the F6 BIOS, which is the latest BIOS for this motherboard. This F6 BIOS does not fix the high training voltage issues. So at 1.5 volts, the board will still train sometimes. Like, if you're running less aggressive memory settings at 1.5 volts, it'll actually train. But 1.55 volts tends to have serious issues. 1.6 volts does not work. So yeah, that sucks, and that's why I'm down at like 1.47 volts. It just makes sure that you don't get the 4C 4E reboot loop on this motherboard. So that's what's going on with that. DDR VPP and termination are on auto because there's really no reason to adjust them with the memory settings that I'm running right now. And then this is just CPU overclock settings, which don't really matter. Like, nobody wants to run their 12900K at 4.8 gigahertz. It's down to 4.8 gigahertz because of the air cooler, right? So, anyway, let's talk about the actual memory settings. So, yeah, 1717, 1728 primaries, which is pretty standard for, well, the thing is, I've generally not had CPUs that would, like, run these kinds of memory speeds, so... I'd say this is pretty normal for BDI, or at least like good BDI memory at these kinds of memory speeds. And for the secondary timings, 16 TCWL, because generally speaking, your cast write latency should be 1 or 2 ticks down from your cast latency. And that's not like for optimal performance, that's just kind of like generally that'll work. Sometimes you can push it even lower than that. But you might find that it'll be really hard to stabilize. It might not even post if you push it too low. So yeah, and in my experience, it doesn't make that much of a difference to performance. So I generally just go with the rule of if my cast latency is X, then cast write latency is X minus 1. Anyway, TRRDs, we've got 4.5. At lower speeds, generally you want to aim for 4.4, but at higher speeds, 4.4 sometimes just won't be stable. So 4.5 for stability, and the performance loss going from 4.4 to 4.5 really isn't much, because this only, like, the way these two timings work is that ideally most of the time the memory should be using the short delay, not the long delay, and the long delay is only 25% longer, so it's not like this isn't like you're making 100% of this operation 25% longer. Just sometimes this operation takes 25% longer. This is sort of the way to look at it. Anyway, so TRFC is at 300. This would probably go lower with this memory kit, but the thing is, 20 ticks less TRFC does not make a huge difference in performance. So I just kind of leave it at 300. And most BDI memory kits will bottom out somewhere between like 240 and 300, though it also depends on what memory speed you're at. At 4600, you generally can't run as low a TRFC as you would at, say, 3800. So yeah, that's why it's up at 300. Like 300 generally will work from like 3600 all the way up to even over 5000 megabits per second. Not that many CPUs can reach those speeds, but yeah, so that's just kind of what I have it at because I'm lazy. I don't really feel like figuring out where the limit for that is, and the performance compared to, auto is already a lot better, because auto at this kind of speed you'd be looking at, I think, 630, probably maybe more than that. So anyway, TFAW is at 16. This is as low as you can set TFAW, so just always set it to 16. Command rate 1, which is not actually 1T command rate because we're in gear 2. So the memory controller is actually sending commands every other memory cycle. So this is effectively, like if you were comparing 1T command rate in gear 2 to how 1T command rate works in how command rate works in gear 1, this is the equivalent of like 2T command rate in gear 1. And you can actually check the Intel documentation, which says as much. Also, there is a gear... I'm not sure you can go into gear 4 on DDR4. Okay, you can't. But on DDR5, there's gear 4, and in gear 4, 1T command rate is actually 4 ticks, because the memory controller slows down to 1/4 the memory speed, instead of 1/2 the memory speed. Anyway... So yeah, command rate just set as low as it goes because in gear 2, that doesn't cause any stability issues because it's actually kind of loose compared to what it would be in gear 1. Anyway, then TREFI we're at 44,000, which is just sort of like a nice safe value for BDI at this kind of memory speed. TXP at 4, this helps with memory latency, though I don't believe it's actually applying because the BIOS is reading it out as 8. So... Anyway, but generally, if you can set your TXP to 4, you should set it to 4. It makes your memory latency better. And I guess that's bugged out on the DDR4 memory controller. It works on DDR5 though. So yeah, that's weird. TWR PDN, no, TWR PDEN 32 and WR pre 32. This is how you basically configure your WR timing to 12. Technically, you could probably also just punch in 12 over there on this version of the BIOS, but the thing is, on an earlier version of the BIOSes for this motherboard, that wouldn't work. So the reliable way to set this is through here. So you just set those to 32, and that gives you 12 for TWR. Anyway, TRD pre set to 8, and that sets the RTP timing. If you tried to set this was also an issue on one of the earlier BIOS versions. If you set the RTP timing directly, it wouldn't post. So it's better to just set it from here. And whatever value you punch in here is what you get for RTP. So if you want RTP 12, you punch in 12. If you want 6, you punch in 6. And I have it at 8. A lot of BDI will actually do 6, even at memory speeds like 4600 megabits per second, but I'm lazy. I don't really feel like troubleshooting, mem test errors if I can avoid it by just running slightly looser timings. So slightly looser timings it is. TCKE 4, you cannot set TCKE lower than 4. There are some other boards that'll allow you to set lower values. The memory controller does not support anything less than 4. Anyway, then we get to the tertiaries, and these are a bit looser, like potentially something like 7.4 would work, but again, I am lazy. I do not feel like fighting memtest to completion. So yeah, 8.4, and the DR and DD timings I could have left those on auto. They do not apply in this memory configuration because obviously we're running single rank memory sticks, so yeah, the different rank and the different DIMM timings, they do not apply because each channel has one DIMM on it and one rank on that one DIMM. So there isn't a different DIMM and there isn't a different rank. But yeah, so I could have left those on auto, but for aesthetic reasons, I just set those to 4. Because it's more visually pleasing to have 84444 than 84 auto. Right? That's literally the logic for that. You could also set them to 0. Well, actually, you can't set them to 0. Yeah, so the Gigabyte BIOS won't let you set them to 0. There's other motherboards that'll let you set them to 0, but Gigabyte won't, which is probably a good thing because technically you can't actually, like if you did have other ranks and other DIMMs, you can't actually set them to 0 or 1 for that matter. You can't set them lower than 4. It's just memory controller doesn't support that. Anyway, read to writes, we've got 16, 16, 16. Again, like the DR and DD values are not used. These would potentially go slightly lower, but again, I didn't feel like trying to, troubleshoot memtest errors too much, so I left them at 16. Like, I wouldn't necessarily be too surprised if, like, 12 worked, but I'm lazy, so... And this isn't really a practical memory overclock that anybody should be running. It's just kind of like, well, this works. If you want to, experiment from here onward, if you want to experiment with something like this for your own use, then knock yourself out. I doubt it'll be a productive way to use your time, but, I'm not going to stop you. Like, I went and did this instead of doing something productive, so evidently I have a problem. If you have a problem too, then you can join me. Anyway, write to read timing. Oh wait, I should go right to write. So write to write, just 844 again. Same like with DDR4. Generally, whatever you can run for your read to read delays, you can run for your write to write delays. And again, the DR and DD timings do not apply. Write to read, same group, and write to read, different group. 32 and 28. Potentially something like 28, 24 might work, but I do believe I tried that and it wouldn't post. So yeah, 32, 28 for that. And then for the round trip latencies, I don't see, so with some of the, like in the past with this motherboard, it was sometimes necessary to lock the round trip latencies, in Gear 1. But in Gear 2, I've not seen them mistrain yet. Like, at these settings here, they've always been 50 and 48, which are acceptable values, so no reason to change that. Though, potentially, if you wanted to make absolutely sure that the memory controller couldn't, like, mistrain them, you could lock them into 50 and 48. That should work just fine. And then we've got the terminations, and this is actually kind of important. So it turns out the default termination values that this motherboard likes to use, which are 2160 40, they do not work. Like the 2160 part of that apparently doesn't. Well, actually, for single rank, I think park isn't used, but I think it's parked. I'm not like there's one termination that is specific to dual rank or yeah, dual rank memory configurations. I'm not sure which one it is. It's just one of those things I forget very regular. Like I read it once in some documentation and I never bothered to remember which one it actually is. Either way, either the 20 or the 160 is a problem because until I set both of these to 8080, I was having some like weird minor instability issues, which was really like, which initially made me suspect like the TRRD timing, but it just wouldn't go away until I set these to 8080. And so at this point, I'm convinced that if you're running Samsung B-Die on Gigabyte DDR4 motherboards, you should always set your terminations to 808080, or because for dual rank, I actually was running 808080. So you should basically set your terminations like this, pretty much always. Though in this case, I was running 8080 auto, which actually would be 808040, right? As you can see over here, that like the right termination, which I didn't configure, that's actually set to 40. So that seems to work just fine. But the default values of 21, 60, 40, they don't seem to play well with Samsung B-Die. I imagine they're tuned for Hynix DJR. Is my theory. I suspect those are set up for Hynix DJR, but I've not messed with Hynix DJR on Z690 very much because DJR is, it's like the problem I have with Hynix DJR is like it tends to be kind of expensive. Like if you want high-end DJR, it's actually really expensive, and it's slow. Like it clocks, like it'll do higher memory speeds than B-Die does. It just does absolutely god-awful timings, so it's kind of useless, in my opinion. Like, your TRCD sucks. Your TRFC is not great. Your, I don't think you can run quite as low TRRD as you can with B-Die. Your cast latency generally doesn't go that low either. Like, it's just kind of loose. And it's not a huge difference, but it's like if you're going to be buying high-end expensive memory kits, why would you buy slow high-end memory kits? Like, why would you do that? So, yeah, and also it doesn't have like a density advantage, right? DJR, you're looking at 8 gig DIMMs. I guess dual rank DJR is a thing. And maybe dual rank DJR would actually make sense because that would offset some of the like sub-timing looseness, but or just general looseness. But at that point, like, there's also Micron, which you could run in single rank, and that's generally going to be slightly tighter than DJR. And that might make a lot of sense in Gear 2, actually, because in Gear 1, it's not great. Not great in my experience. So that's something I want to test in the future. Yeah, so maybe, and for Micron, maybe these termination values would actually work just fine. But with the B-Die kits that I've been testing on this motherboard, it's basically always been like 80, 80, 80, or 80, 80, 60, and I guess 80, 80, 40 also works. So, yeah, but so the auto terminations on this board definitely don't seem to play well with Samsung B-Die in my experience. Even, like, I thought maybe in Gear 2 it would be somewhat different, because Gear 2 is general, like, the way the memory controller behaves in Gear 2 is usually pretty different from how it behaves in Gear 1. But no, it just doesn't evidently B-Die really doesn't like these termination values that Gigabyte just defaults to when pushing the memory. So, yeah. Anyway, that's kind of that. That's really all there is to it. So yeah, Gear 2, B-Die, 4600. What I find really interesting is compared to Z590, it's super easy to also boot like 4800. Though I've not had much success stabilizing 4800, I suspect it might have been a termination thing. Because the thing is, initially I thought the like random one-off errors was like just memory controller instability, but we're just going to quickly test that right now. So we're going to loosen this out, because previously like I was loosening out timings and everything in it, and 4800 just would not run. So I'm kind of wondering if we try something like this with the same voltage, if it'll run Y-Cruncher, because that was the main issue. Like, I couldn't run Y-Cruncher, and when I couldn't run Y-Cruncher, I was like, oh, maybe Y-Cruncher is just getting too hot, and so I decided to try, say, memtest. Memtest also wasn't running, so the usual rule of, like, if it can't run Y-Cruncher, it won't run memtest still holds. So, yeah, and it looks like I might have screwed something up. Yeah. Luckily, the board has a safe boot button, so that's not really a huge problem. So actually, yeah, we're going to extend this video for no reason. It's not like this was a particularly useful DDR4 overclock in the first place. It's just like, it has occurred to me that, you know what? I didn't test 4800 with the terminations fixed. Wait a minute. Did I set them all to 80 again? That might be suboptimal. Oh no, they're 80, 80, 40. Okay, no, so that... Oh, I set the RTLs. I'm such a... Yeah, you don't want to do that if you're changing memory speeds and cast latency. Actually, like, if you change... Like, you do not lock the RTLs if you're changing things. You do that after you have everything else set the way you like it, then you can go lock the RTLs. Otherwise, it will not post. And we've got the 9C error. So this is really annoying. This just sometimes happens where the board will not initialize the GPU correctly. And this happens kind of a lot on Z690. Like, this isn't the only board that does that. Where it'll boot up and it won't initialize the GPU. And you just have to restart through that. Probably some side effect of PCIe Gen 5. It doesn't give you any extra performance, but it does make your GPU unreliable. Isn't that great? This is a Gen 3 GPU. Yay, new capture card is doing its new capture card duties very well. Okay, so let's see if I can run Y-Cruncher. Because previously, at 4800, that was completely out of the question. There was no way. But I didn't have the termination set. Okay, nope, still won't run. Okay, so I guess it does need just an absolute truckload of system agent voltage. Because that was my other theory. It's like, either it's not enough system agent voltage, or terminations. Well, the terminations were still bad, because I was having other, like, stability issues. Even at, like, 4600, I was having stability issues, but... Yeah, I guess... So I've already tried 1.45 volt system agent in the past. So I guess this time we're going to try... Also a bit more CPU voltage. And the 1.26 I think is borderline, because I do have it on low LLC right now, so... Yeah, anyway, I would not recommend this for long-term use. I'm just wondering if this will get Y-Cruncher to pass. Right, like, I would not daily 1.5 volt system agent, especially not on a 10 nanometer CPU. Kind of wondering if maybe the tertiaries aren't too tight at this point. Because that was the other thing, is like initially when I was messing with Y-Cruncher, I wasn't setting the tertiaries. I did loosen out cast write latency, so it should be okay. Okay, capture card being a bit weird, I guess. Still better than the old one. Remember the old one? I'd have to unplug the HDMI cable every time we go into the OS. And man, it really doesn't want to run Y-Cruncher right now. Okay. I don't want to give up right now. I do have issues. The thing is, I got it to, I think, 70% at one point. No, 50. Yeah, at 4800, I definitely got it to like 50% or so. Oh wait, I have the memory voltage really high. Yeah, that might do it. See that? Yeah, so like the board and high memory voltages just don't seem to get along, so that might be part of it. No, not VCCN. Memory voltage. So, 19. I'm trying to think if there's anything else that might be. You know what? Let's ditch the RTP. It doesn't really make that much of a difference. Well, it won't make that much of a difference to the performance, but it might to stability. And let's try that. Okay, so I guess not enough memory voltage. Because we're getting stuck on 7F, which, actually, no. 1.5 volts should be plenty for CL17. There's a chance the memory controller just won't do 4800. And I'm starting to think that's... Or maybe the voltage is too low. And safe boot stopped working. Oh, no. Okay. Turn it back on again. Safe boot. Safe boot before it fails. So maybe I've not really used like really high system agent voltage, which I would consider 1.5 to be definitely on the high side. So maybe that's why it's acting all weird now. Should be in safe mode now. Yep. So maybe VDDQ? 4, 5. Nope. I keep hitting the wrong voltage there. I don't think I screwed anything up. Let's try, I don't know, maybe it doesn't, like, so, well, no, I was at 17 before, so it can't be, like, sometimes there's, like, issues with, like, odd timings, but no, I was at 17, like, flat 17s before, so there's no way that's the issue. $55, 7F, okay, now it works. And it fails to initialize the GPU. I think the system agent is too high. Because the system agent voltage is responsible for the PCIe. And yeah, 1.5 volts is up there. I don't think this is going to run Y-Cruncher. Like, the fact that I'm struggling to get it to boot, there's no way this was running Y-Cruncher. Evidently, I've managed to make it worse, not better. I wonder if maybe I went back to the old terminations. I don't think, like... Maybe go back to, like, the default terminations, but... Oh. Yeah, no. Nope, it's not running. Okay, I give up on this. So, yeah, 4800 megabits per second, evidently not happening with BDI. I think with maybe some lower load memory chips like Micron Rev B or DJR, it might, like, it should be possible to do 4800 megabits per second. But especially with DJR, I don't think it would be worth it from a performance perspective. With Micron Rev B, it could be interesting because you would actually get 32 gigs of RAM at that point, right? Like, Rev B is a 16 gigabit memory chip. So, yeah, 4800 megabits per second. The latency is going to suck, though. Like, I'd expect, like, 56 nanoseconds worth of latency because Rev B is looser than BDI is. And there's really not much you can... There's nothing you can do about it. It's just, like, inherent to that memory chip. But maybe even in dual rank, Gear 2 might not be too bad on Rev B. Like, if you could do like 4600 or 4800 dual rank Rev B, the issue with that is like dual rank Rev B at that point is 64 gigs of RAM. And running memtest on 64 gigs of DDR4 is very unpleasant. It takes forever. So yeah. Also, you need to spawn like 40 something. No, you need to spawn like 32 threads, which is not great on a 8-core CPU. So, like, it's not great even if you turn the E-cores back on, because those actually make memtest run slower. But yeah. So anyway, hopefully this was somewhat interesting. But yeah, I think definitely I'm gonna mess around with some Micron Rev B in single rank on this, because that like it should have a decent amount of memory bandwidth available. It's just going to be a disaster in terms of latency, because you're going to be with like TRFC is going to be like 600, actually probably more than 600. So yeah, that'll, and then like TRCD probably like 22, maybe more. Yeah, so that'll be like basically it'll take all of the problems that this current overclock has and make them more so. So yeah, I'm still not like, honestly I think best way to go for Z690, especially like specifically for gaming, dual rank Samsung B die in Gear 1. Maybe single rank Samsung B die if you don't feel like, if you don't need a lot of RAM, or you just can't. Well, the thing. Well, I'll look into testing some dual rank configurations that aren't specific, like aren't Samsung B die. Probably CJR. Maybe actually no. I have 2 sets of DJR, so we could test that. Yeah, I have multiple sets of DJR, so we could test that. The reason I wouldn't use Micron in Gear 1 is just Micron Rev E specifically is horrible to get working on Intel platforms. And Rev B works great, but it's very loose. Well, actually, Rev B works great, but it's like Gear 2. And it does, like, well, in dual rank, Rev B is 64 gigs of RAM, and it's just like, I'm not stress testing that. I'm just absolutely not interested in stress testing that. So, yeah, this is a really rambly, sort of pointless memory overclocking video at this point, but, you know, I figured it might be interesting for some people to see what's possible with dual ranks, single rank B die in Gear 2, and on this motherboard. And, you know, if you want to mess around with it yourself, then you can sort of base your adventures off of my settings. Probably maybe want to start with looser primaries, right? CL17 at 4600 might be quite hard on some memory sticks. But these Teamgroup, like the thing is, this Teamgroup kit that I'm using here, this is literally, like, these are tied for second place in my memory collection with a bunch of other kits. So these are definitely not like the worst. Well, when I say bunch of other kits, like they're tied for second place with, say, the Patriot Viper Steels that I have, though these do better on 1T command rate in Gear 1, not Gear 2. Gear 2 doesn't have 1T. And then they're tied, well, yeah, so they're basically tied with the Patriot Vipers, but they beat like a bunch of other B-die memory kits that I have. So, you know, like this is really... Basically, what I'm trying to get at is, like, this is not bad memory, right? It comes at 3600 CL14, so you'd kind of expect it to be pretty good. Anyway, yeah, so that's kind of it for the video. Hopefully it was somewhat interesting, though probably not very useful. And that's it. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. And that's it for the video, so thank you for watching, and goodbye.